Hi. So I'm Eva, as Marco said, and today I'll try to tell you more about Git and some useful tips that you can do in your daily work. So first, how many of you are actually developers and writing code? Okay. And how many of you are using Git? Okay, that's good. My presentation will fit. Because it's not for totally beginners, it's mostly for some useful commands that you can use. Okay, so first, a bit about me. I like traveling, swimming, hiking. I'm also a yoga teacher, and that's basically what I like to think about me. But usually how my day goes is something like that. And I'm a WordPress developer. I'm mostly debugging code now on different projects. I'm working for Cloud Favorite. We are creating digital solutions for some of the biggest enterprise companies in the world. That are some of our biggest clients that we can tell about. My team, I'm lead of ongoing client support. My team usually does fixing of issues of some of our old projects or adding new features to these. So what is really important in my work is version control system, because I usually need to know who, when, and why change some kind of code. And also I use it to work in real distributed company. We have offices in USA, we have offices in Romania, me in Bulgaria, so we are in different time zones, and we need to sync all the code in the end. Why also the version control system is very important? Because if you, for some reason, break anything, you can revert, and you can start over from whatever you're working before. So let's see some different workflows using with Git. And first, let's take a look on the branching idea. So what's good about the branching idea is that you can create a new branch from your working tree, and you can have your stable code and then create something new from it, add new feature, test it, and if it's working good, merge it again to your stable master branch. What is very important to do here is always to pull the code that you have before, because some of your colleagues are working too, so you need to get their changes before you start working. Then you can create a new branch with git checkout -b new feature branch, whatever feature you want to add. Do your changes, add your code there, add your code to Git, and then commit it. Of course, if everything is working good, you can merge it to the master branch that you need. And if you need to see the changes, you can try that git diff command between the branches that you need. So let's take a look on some of the more popular workflows that people are using. First of them is git flow. I would like to show that. Is that working? Yeah. Let's imagine that you have a master branch and you need to add a new feature. You also have always a develop branch in this flow. So the develop branch or staging branch, if that's what you prefer, is used to be tested on a developer staging server. The name doesn't actually matter for me. The idea is the same. So you have a develop branch which is created for master, at some point. And you are creating from this develop branch a feature branch where you add your changes for your new feature. Your colleague can be creating another feature branch where he's creating changes for his feature. So when you are ready, you are merging these changes again to the develop branch, deployed, for example, on develop server or whatever place you test your changes, test if everything's working well, and then prepare a release, which is here. Add documentation, fix some things in the code if you need, and then merge that to master, where you can git tag it with the version. That's your next stable version of your project. Let's say that in your version that is already on master, an end user found a bug. So this is when you create a new hotfix branch from master, fix your bug, and then deploy it to master to fix the problems of the end users. Also, you need to merge it back to develop, so you have these changes there too, and they're not interrupting the work of your colleagues. So that's the Git flow. The next one is GitHub flow. Here, the actual rule is always branch from master. The master is your stable, reliable code, so that's where you start working on a new feature. So you're creating a new feature branch from master, do your work, commit the changes, then in this workflow, you submit a pull request. The pull requests are very useful when you want to check your changes with your colleagues, or you want to check the standards, or you just are stuck and need some more help on what you're working. Then they comment on everything that you're doing, on your commits, and when everything is tested and everything is working, you merge it back to master. I personally prefer something between these two workflows, which again have develop and master branch, but I'm not branching from develop because we can have few people working on few features, and some of them may not be ready yet to go to master. So we usually branch from master and then work on the feature branch, merge it to develop, and if everything is working correctly, merge the feature branch to master. Of course, there are different workflows, different teams, different situations, so you can use whatever is better for your situation, but these are some of the popular workflows. Let's see what the problems are with these. Merge conflicts. This is happening when two or more people were working on the same lines of code and you try to merge something that someone already changed. How you can prevent it? You can, as I said in the beginning, always pull the changes that are done from your colleagues or your team and try to have everything up to date so that is not messing your work. But if you get to the point with merge conflicts, how you resolve them? You have usually the branch that you are trying to merge to and the branch that you are trying to merge. They have the same changes on some lines, and you need to see what's good and what's not. So you just need to pick. That's not correct in our situation, it's just an example. So you just need to pick the change that you want to leave in that file, then add the file and commit it again. What you can do also to prevent merge conflicts, that is git stash. What git stash does is saving your changes that you have done in your work directory and put it in a git stash stack. So then you can bring them again if you need them. How that works? For example, here I have an example project called Belgrade WordCamp, and I've changed one file on it. But let's say that I'm using git flow and I forgot to create a new branch. So what I did here is doing git status, it's showing me what I changed. Then I'm doing git stash. As you see, what happened is git is going back to the previous commit and it's stashing these changes. So when I'm ready and when I did whatever I need, which is creating a new branch as I needed, I can do git stash apply and revert these changes here. As you can see, the changed file is getting back. There are two ways that you can do that, git stash pop and git stash apply. The difference here is that with git stash pop, these changes are also deleted from the stash stack, and with git stash apply, they're staying there, and if you need to delete them, you need to do also git stash drop. I use that only also for some servers where I need to git pull something and someone changed files that I, for example, don't know why are changed. So you can like stash them, pull your code, and then bring them back. It's very useful. Let's say that you need to see what happened in some file to resolve your conflicts or to just check. Git blame is a very useful command. How you can use it is to do git blame -l on the line you want to see the changes to the line that you want to see the changes. And as you can see here, I want to see the changes between line 19 and 21 in that file. And you can see here the commit reference, when it was done, by who, what are the changes. When debugging code, as I am doing almost all the time, that's also very useful. So git rebase and git merge also do like similar things that you can do with branches, but not the exact same thing. How rebase is working, you can check out your feature branch and you can rebase to master, for example. What's the difference here between merge and rebase? The difference is that, as you can see here, if you, for example, have this branch with the commit C3 and you want to merge it to this branch, what merge is doing, it's creating a new merge commit, C5. So merge is creating a commit with the same changes. The problem here is that it is creating a more messy working tree, but you have a merge commit and you can see when the changes were merged and why and so on. Instead, rebase is doing a different thing. It's actually adding a phantom commit C3 prim that is adding the same changes without merging, without new commit here. So that can be a very big problem when you're working with a lot of different people. This can mess up their working tree a lot. So what happens when you really messed up? What you can do is git cherry pick. Git cherry pick is really useful when you have like 15 commits and half of them are not correct, half of them are, and you want to perceive the work that is actually good. So how you can do that is, for example, you can use git walk. That's a bit like extended with pretty one line. What it will do, that's here. So you'll see the commit reference, you'll see the change that is done. Then you can pick the ones that you want to stay. Create, for example, a new clean branch, so you can perceive only the changes that are needed. And do git cherry pick by the commit reference of the ones that you need to be perceived in your working directory. That's when you need something, when something of your code is working. But let's say that nothing is working, so you want to reset or revert. What's the difference between reset and revert? Let's see first for the reset. Let's imagine that you have a feature branch with these 3 commits here, and these 2 are not working. You want to just get rid of them. What you're doing a reset, and these 2 commits are just disappearing. They're disappearing of everyone's tree. So let's take a look on revert then. The same situation. You have 2 commits here, and you want to go back here. What revert is doing, it is creating one additional commit with the deleted changes. So when someone pulls your code back, this won't break his working directory, this will actually add a new commit. And yeah, it's better to not get there, but it's very good when you need to fix something quickly. So let's take a look on the submodules. That's a way to incorporate another repository in your repository, and it's very useful when you, for example, have 10 plugins that you're developing or you're just using, and you want to put them in different projects, and you want to easily update them, change them, and so on. So what you can do is git submodule add, Now, here you add the submodule reference from GitHub, for example, and the path that you want the submodules to go. What this is doing actually is it is adding lines in your .git modules file, which contains the information about the name of the submodule, where it's located as a folder, and the reference for its GitHub path, for example. Then also you're getting a folder in your working directory. It's not an actual code until you pull it, but instead it is checking out a commit, the latest commit in this submodule repository. If you see it in GitHub, for example, or as a commit, it's just a commit reference there. So how you check out a project with submodules? This is like, I use it a lot, and these are my 3 favorite commands, just because they initialize submodules. Git submodule init, git submodule sync the submodules, because you can have different versions of the submodules in a different branches that you have. So when you switch branches, that's also very useful. And then git submodule update -- recursive. In fact, that's useful when you have submodule in submodule. You can have that. You can have incorporated few projects in one. So as I said, it's very useful for plugins or frameworks or whatever you use on a lot of projects. But sometimes, you want to remove it. So this is a bit more complicated than just deleting a directory with a plugin. You need to do git rm -- catch submodule path, where it's deleting this git reference here. Then you need to delete not the whole file if you don't want to delete all the submodules, but the lines that are responsible for this submodule in the git modules file. Then you need to remove the git directory that is responsible for this submodule itself. And here, about the next two, it really depends that you want to perceive that code or you want to delete it at all. If you want to delete it all, you can just do it with rm. And if you want to just add it as a normal code, not a submodule, you can just git add it and commit it like a normal folder. How you can update them? That's a very frequent situation, especially with plugins. So you can go to the directory of the submodule, check out master, because it can be detached to a branch, specific branch for a project, or specific tag for this project. So you need to just check out the master, git pull it, and then you can, of course, pick here which branch you want, which commit you want to, or whatever is useful for your project, and then add it and commit it, of course, like a normal change. And the last thing that I want to mention is tags. I mentioned them in the beginning, just like part of the Git flows. How tags work? That is option to tag your stable versions of your code. Instead of branches, tags, as I said, are stable versions that you want to be able to check out faster. Branches are not about that. They are more about adding development code features and so on for active development. So how this works, git tag lists all the tags in your project. Git tag -l, for example, some reference, is listing everything with that reference. You can add tags with git tag -a version that you want and a message that you need. And if you need to show everything that happened in that tag, you can use git show. Of course, you need to push them back to your repository. And you have stable version tag, so you can, for example, in the submodules, you can check out that version more quickly. Or just have it like a reference for your colleagues. And mostly that's it.